guys, just looking at the Trimble MX60 data workflow in this T7 Shield drive. I've got two folders, but we'll look at this file first here. This is the raw data file that we've dragged off the two 4 terabyte hard drives. It comes in two different drives, but you just collate them together into this one package. This is the folder that I've added after the fact. This is my base data, my TO4 file, so that we can post-process the trajectory. Under here, we've got different camera files, a little coverage map, which is just a KMZ of the trajectory that was ran. And I'll show you that in Google Earth, what that looks like. This is automatically downloaded onto the drive. You can see here, this is what is being driven. I'll show you in a different video the TMI, or Trimble Mobile Imaging, the workflow there. But you can see, if you zoom in, where the line is thick is where we've captured LiDAR and imagery, and where the line is thin is the approximation of what we've captured in the mission. The terminology I'll come back to in a second, but this is a good gross check or indication of what data is being captured without having to import that into TBC. You can look under that. So that's a coverage map there. A couple of laser files. We don't really need to deal with them in the raw instance. The POS is all the positioning, the GNSS and IMU data captured. And then what is sometimes useful is this report. It comes through as a HTML, where you can look at basically everything that's been set in the field. So through here, we've got the mission ID, the name, the date, the time it was captured, mission configurations, what vehicle we used, if you'd added any information on the runs, or literally anything and everything that you could ever want will be stored in this file. But for the most part, we don't need to deal with it. This UTC time is certainly very handy if you're downloading your cause data, so you know exactly what you need to download rather than having to import that file. And if I go back into here, what we're really interested in is this MXDB file. That's our database file, which will point to all the relevant data in TBC, and that's how we're going to import this data. So for now, what I'm going to do is I'm going to jump into TBC. I'm running 2025.21 here, but what I'm going to do is I'm going to start a new project. I'll start a blank template. This is a new build for me. All my templates are gone. Once I'm in here, I need to ensure my license is correct. So under my support tab, license manager, make sure, if I'll send you a mobile mapping subscription, but make sure you're under subscription. Make sure this is mobile mapping and just hit OK. This grid button down here, and that will open me directly my project settings in my coordinate system section. Otherwise, you can select the little project settings symbol at the top. It will just not necessarily bring you directly to where you want to be. So either way, it's fine. We're going to change our coordinate system. This data set that we're looking at is GDA 2020 zone 56 in the recently used one. So I can just use that one and hit OK. So now I can see down the bottom here, I've got my coordinate system defined as zone 56. From here, what I want to do is import my data. So for mobile mapping, if I go to the mobile mapping tab, It gives me a little bit of a rundown of the process required. One thing it doesn't have is obviously the import function, so I will use this little import button at the top. Otherwise, you can use under the home tab, there's a bigger import button. For mobile mapping workflows, I would suggest you use the import button and import tool as opposed to dragging and dropping. And there's a few reasons for that. Let me go to my folder. So if I go to my drive, I'll just open that one. I want to point it to this raw data file. So this TMX60 blah 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 is all of my raw data. So if I open that one and give TBC a second to read the file types, you can see here it's read and recognized this MXDB file as a known file type, a mobile mapping database file. What it's going to do is it's going to read all the information that it needs to by importing this one file. So it's a database file. I will import this. And I will now import again my base data. So this is the folder that I've saved my TO4 in. Any base station data I need can be either TO4, TO2, Rhinex, any standard logging file can be used. But being a Trimble proprietary, we're going to use this TO4 and I'll import that. When you import static data, this receiver raw data check-in will pop up and it'll give you a bit of information around what the point is called, the file name, when it started, when it stopped, the duration. You can click on the antenna and see a bit more information. So we can see here we've used an R12i and you can see the method for the height. So if there's an error in the heighting, we can amend that there. If you go to the receiver, you can see a little bit more information. If it's a single base, what the serial number is, and so forth. It's always good practice just to run your eyes over these sections, particularly the heighting, to ensure there's no errors in the heighting being introduced. I'm happy with that, satisfied, so I'm going to hit OK. And that will import my point, PM211463. And that comes in as a control coordinate. But if you go into your File Explorer and click it here, you can see it's actually the raw log file. From here, good practice to save. Always save your data. So I'm going to save that on that drive. So T7 TBC projects. I've already got a complete project here called Wave 1. I'm just going to call this one Wave Demo Workflow. The reason it's called Wave is that the project this was captured on was part of a Wave project. That's where that name comes from. Now, once you've imported the data, I find it good practice to check your data against background maps. And really what we're looking for is picking up any gross errors to make sure we've selected the right coordinate system. You'll notice that the roads we've run should line up with the roads in the background maps pretty well. And this is really a bulk gross error check. If I'd put that in zone 55, this wouldn't have made much sense. So that is always a good check. And if anyone isn't aware, background maps, there's a little button down here. Most of these buttons down the bottom will have subsequent sections. So this one you can do Trimble maps up here as well. You can change it to satellite as well as background maps or terrain. If you wanted to keep this in the background and you wanted the transparency to be a little bit duller so it's easier to use, if you select the project within this Project Explorer and open your properties pane, We can actually change the transparency here. So if I punch that to 50, it dulls it down a bit. But for now, we don't really need it, so I'm just going to toggle that off. So from here, what we want to do is we want to process this data to be an RTK solution. So currently in my Project Explorer, I've got a mobile mapping group. I drop that down and I've got one mission, that mission we imported. Underneath that mission, I have a folder which designates what devices has been read in because we've pointed the MXDB data, as well as multiple runs. So you can see here, run 1 through 10 are all individual runs. So I toggle that one off. So you can see here, this little section here is run 1, run 2, so forth. You can see what's been done. So each color of these thick poly lines actually runs. And if I drop down a run, you can see underneath a run, we have a trajectory. So there's a bit of terminology to understand. The mission comprises of all the data in one campaign. Within each mission, you can have multiple runs. And they are where we've captured imagery and LiDAR data. A trajectory relates to the mission. So one trajectory is based on what each run has been tied to. So from here, if I go into my mobile mapping tab, what I can do is I can select my mission or my run, but in this instance I'll select my mission and I want to process the raw trajectory data. If I click that, what it brings up is the pane on the right hand side. There's a few things that automatically get designated. So our raw data folders and our SBET output folders, they're standard. I can choose to back up the SBET. If you're not familiar, the SBET is Smooth Best Estimate Trajectory. Essentially, it's our trajectory data. I'm just going to select back it up because if we need to use that later, it's a bit easier to find. From here, automatically, the reference station has been selected and toggled on. We've only got one. If you had multiple, you would see them all there and toggle them on and off as needed. From here, we've got a computational mode. So in this current build, we've got two. We've got Infusion single base and Infusion Plus single base. For MX60 and MX90, they both have AP plus 50 or 60 IMUs. So we would really want to recommend using this Infusion Plus computation mode. Now, single base doesn't mean you can only use one base. What it means is it's only ever using one for the solution. What this means is it'll only be using one base as a correction source. So in POSPAC, there is a different computational methods, multi-base and so forth. But in TBC, we're just using a single base. From here, we can truncate the start or the end of the project if needed. More often than not, this is not required. At the start of the process, we go through some initialization process. So you can see these figure eights. That kind of really helps resolve the position in whether it be the heading, the pitch, the roll, or any of those kind of metrics. So we actually want to keep all that data within our raw data processing. The GAMs, we could toggle that on or off. In this instance, I'm not going to use it. It's something we can come back to and use it if we need to. The IMU on board of this system is very high-end and is not necessarily required for every job. GAMS is really useful if you're in an environment where you can't do any of this initialization and you can't have that dynamic driving. In this instance, it won't give us that much value, so I'm not going to turn that on. The initialization mode, it just helps. It's telling TBC what data to use to resolve its position. So in this instance, GNSS, we're happy with the data. In this instance, you can use multiple different options. I'm just going to use gyro compassing and GNSS, and what that means is I'm using the IMU data as well as the GNSS position to initialize my solution. The antenna manufacturer antenna type is set. That's what is on the machine, on the sensor unit. Don't worry about that. The multipath, if you're in particular environments where there is a lot of multipath, or there's not a lot of multipath, then you would toggle those. I see a lot of success just leaving it on medium. There's no real need to toggle that unless you're in a really tough environment. That's where you might go to high. Generate QC report. I'm going to leave that on. More often than not, I tick it off, and we'll get into why a bit later. But for this video, I'll leave that on. Now, we could hit compute here, and that would resolve our position pretty well, and it'll be a very good result. But what I'm actually going to do is I'm going to use this LiDAR QC option. And essentially what that is doing is it's allowing the computational process to include the LiDAR data from the scans. Now, we're not actually importing and generating point cloud at this stage, but we're using the raw point cloud in the database file to essentially provide a SLAM solution. So we're using that extra information to resolve our position. Now, this really assists with when you get separation between clouds. This is going to negate that. So I'm going to tick that LiDAR QC on. And because I've ticked that on, I need to go to this next tab, LiDAR QC here, and I need to add what runs I'm interested in. And in this environment, I've got a lot of multiple duplicate passes on particular sections. So I actually want to use all of those information. So I'm going to add those runs, select them in the Project Explorer, and hit plus. From here, I can amend the scan range as to what is it using to help position the data. So in this instance, we want to dial this in to kind of utilize the best position for a SLAM environment. And so what do I mean by that? So if I'm using something out to 100 meters and that's all vegetation and it's not structures, it's not fixed planes, it is going to actually help us resolve our position. I actually don't want it to use that because A, it will have a massive computational load that isn't necessary, doesn't provide any benefit. But B, I'm not interested in that data anyway. So I know within, say, 40 meters of the scan head, and I'll probably leave that at 3. Within 3 to 40 meters of the scan head, that is going to be the most accurate scan that can be helped back process the trajectory. Just like in a SLAM environment. You don't want a SLAM position to be processed off something 100 meters away. You're introducing noise into that processing and reducing the quality. In this instance, we've used an MX60 for this data set. So I'll leave this noise value at 5 millimeters. If you're using an MX90, we would push that out to 10 millimeters. And in this instance, we can select if we want to use left, right, or all of our lasers as part of this process. I'll leave it on all. And as I quickly run my eyes over all this information, I'm satisfied and I want to hit compute. This warning has come up just because I have a dual build on this computer. I have TBC as well as POSPAC MMS, and I want to click yes to use my TBC processing, not my POSPAC. This won't come up for everyone. From here, this view, you will see an information pop up where it's told us the SBET file has been written to a particular folder location on GDA 2020. So we'll hit OK on that. Now, since we clicked this Generate QC report on, this file will open up. It's just a PDF, but it will open in, whatever your standard PDF viewer is. In my instance, it's just Google Chrome. You can see sort of all the information you need from this file. You can see it's 59 pages, so it's pretty robust. It's got all sorts of information in here, particular sort of lever arm distances from your IMU. It's got all satellite angles and what's been read from each constellation, and it's kind of got anything and everything you could ever want in terms of data. You can look at your roll pitch values, velocity, speed, anything and everything. It's kind of a bit overwhelming, to be honest, but it can be a good file to keep if you wanted to file it, just as a documentation of your results. Now, if you didn't click that on, you still have all that data available in that trajectory plots button. I'll just drag it over this button here. It'll look like this, and you've got all that same information in this dialog box. So, depending on your workflows, you can save it however you wish. This is actually a data set that I turned off Lido QC, but you can see all these same sort of values, XYZ angular rate of the process in these environments. A smooth performance metrics is a good one. You can shift click northeast down and have a quick summary of the results and see what sort of quality the data is. You can see here, as you'd expect, GNSS position, about 10 mil horizontally and 20 mil vertically is what we typically expect for a traditional RTK MLS capture. So that's it for this little view. You can just close that. You can open that anytime. Now from here, what we really want to do is, you can see this compute button's being grayed out. So we've computed a solution. But if we go to our Project Explorer and look at a particular run, we've only got the autonomous nav SBET trajectory in there. So that file that we've since computed has not actually been applied to the TBC project. So we need to go through and hit apply to actually save and load that SBET file into this exact TBC project. So if I hit apply here, that will then just load the file in. You can see this little load bar down the bottom. And if you quickly look in the Project Explorer, you can see that I now have two trajectory files in this particular run: my autonomous, my nav, and my SBET2, which is my post-process raw trajectory data, which is ultimately an RTK solution. So you can see here this green trajectory, that's actually colorized based on the quality. So if you click this trajectory settings, you can see what the RMS values are and how it's been colorized. So that's a good indication to quickly tell that the data you're looking at in your plan view is actually post-process. So you can see here, this is where we've done the initialization. At this little tippy top point, there's a little gray bit. So you can see that area there has a bad RMS value because it was the initialization, the first point in time. So if we get out of that, we can look at our whole mission campaign. So from here, we've got the one mission, and what we want to do is we want to generate scans. So if I select the mission, you can see this is the left to right workflow. Again, coordinate system, process trajectory. We skipped split run. So this split run enables us to kind of cut sections where we might have forgotten to stop runs in the field. So in this instance, you can see there's a little loop that we've computed is one run, where maybe we had intended for it to be two separate runs so that it can be treated independently. So this gives us the option to do this after the fact. So if I select that trajectory, so this run 5 is the section that we're interested in. I want to actually split that run. Now it comes up with the tool, select into the run, and we can really just click where we want it. So we can split it in half there, but maybe we want to actually delete a section of it. So I'm going to cut sort of that loop off. If I click that point there, and that's where it's going to run, it tells me a UTC time as well as distance from the beginning. I hit OK there. Now that splits run 5 into 2 separate runs. So you can see if I turn that one run off, it's split into 2 specific points. And so if I wanted to get rid of the rest of that loop, I just select the other run. And if I wanted to, I can go change the colors of these trajectories so it's easier to see. Just in the project properties, run properties. And so I want to split that run off here, just to line it up. That's why that colorization is handy. And now I've got run 5 split into 3 separate runs, of which that run 5_2_1 is actually trash. So I'm going to name it accordingly. I don't want scans to be generated in that section, or I might not want to. This is just an example. And I've done it Z so it gets sorted alphabetically, and I'm just going to rename that run 5_2, and now that is treated separately. So that's just an example of where we may want to split runs. Some people in the field don't start and stop their runs. They just let it run for the whole time and do their splitting after the fact. That is an option. Kind of horses for courses a little bit. So from here, we want to generate scans. I'm going to select the mission. Or you could select run, but I'm going to select mission. Hit the generate scans button. So you can see I can't actually select it if I don't have something selected. You can see in all these buttons, it's a good indication that you need to actually select something in the plan view, or I always select in the project explorer. If I hit generate scans now, that will come up. If I select the mission, it will turn everything on immediately. So you can see it's actually split chronologically. But if I select one run and hit generate scans, just that one run has been selected. Same tool, same functionality, it's just being selected differently. So here I want to keep everything on, but I'm just going to get rid of that trash layer because that's something I don't want to produce scans on. So it is chronological. If I toggle that off, that won't generate the scans just in that particular section. So if I hit next, this is the quality or the filters option. So from here, really, I don't even really mind about these 2 default options. What I'm going to go straight for is I'm going to go straight for the advanced settings. And what we're doing here is we're just filtering the range. So how far from the scan head do we want to produce a point cloud from? I'm not really going to change the minimum. Probably a rare instances that you need to amend the minimum range. But the maximum range, this 150 meters is the maximum range of the MX60 instrument, which is what we're running here. We really rarely want that sort of range in mobile mapping environment, particularly in this built environment. So I will cut that down. Down to 50 meters. Go next. Now this option is a scan configuration, so it's good practice just to check the trajectory selection is correct. In this instance, I want SBET2. If I drop that down, you can see there's a nav position there as well as the SBET2. So just good practice to check it's on the right one. Usually is, but doesn't hurt. Now from this section, we have the option to colorize the point cloud with the panoramic imagery, which is binary, yes or no. And in this instance, we need to or we haven't, sorry, created a vehicle mask. So this is a new data set. I'm going to create a mask, which is something you only need to do per vehicle setup. You don't need to do this every time, but I will show you what it looks like. So I'm going to hit that button and it will save 6 photos, one of each camera on the 360 drive, into my TBC project file or wherever you point it to. So you can see here I've got my 6 images. They're PGM images in my TBC project file. And I want to open these in a project that is called GIMP. You can use any image processing software. So once GIMP is opened, this is what the image will look like. It's just one image. I'll go through and just black out the regions in this image where the image is black. It won't use that section for colorization. So I'm looking at just coloring in the sections of the image that have any sensor unit in it or vehicle in the forward-facing images. I'm just going to speed through this section, so I'm doing it for all 6 images. Very rapid here. But in this particular software, you go into your file and go overwrite once you've completed that. And you can discard those changes. Make sure you overwrite those existing images with the masking. And in TBC, you can see here it points to the folder location where they have been generated. If you do this all the time, you can store it at a local drive location and use the same mask file. You can see here it's just pointing to one image, but it is looking at the whole mask, which comprises of all 6 images in that package. Here we have a colorization setting. No preference is the standard. If you're getting tailgated, or if it's mounted at the back of a train where the front-facing images aren't going to provide any value, this is where you might apply some of these settings to that scenario. From here, we'll hit process. This data will now come through in the process view pane, and you can see that the mobile mapping data is being processed and the scans will be generated. Once on completion, you'll get this error message, that shows you what settings have been used and the range that's been applied, if colorization was turned on or not, and if there's any filtering being applied. So at this message, you can just hit OK. And if we go to our plan view, you can see, turn off our maps, background maps, you can see the point cloud has been generated successfully. So now once we have a point cloud processed and generated, we can go through and open a 3D view. I use this button up here. There are, as mentioned previously, multiple avenues to open that. So you can see I've got a data set here that is producing scans for all of my runs. This particular data set was a LiDAR adjusted data set. So if I go to an area where there are multiple passes, you can see here there's 3 different passes on this location. If I go open a limit box and just kind of QA that data, just a little cross section, just a thin slice there, you can see I've got one cohesive data set that has multiple passes. So I'm satisfied with this data. And from here, what I might want to do is do some registration. So if we again follow the bouncing ball and go along with this workflow, we finish the generation of scan, we might want to register a mission. So you notice this is gray. I'll just go to my plan view. You notice this is grayed out. The reason is I've selected a run, so I I need to select a mission if I want to do that registration workflow. So I select my mission here. I could go through and hit register mission. That will come up if there is a particular job already complete in this job. I'll say no. This starts a new one. You can give it a name and a registration type. So there's 3 different options here. Global, then local. I'll come back to that. A global shift is simply a block shift where it's keeping the current position of all the data set and doing a best fit, a big global shift of all the data. A local shift here is when you are just adjusting the trajectory based on the local position. So if you've got large distances that don't have control, it won't shift that data. It'll shift it locally around the control. And then obviously the global then local, that's doing both. So it is literally as it says, doing a bulk shift of all the data, best fit of your control, and then kind of getting rid of those smaller residuals, doing a localized adjustment around each control. I would often suggest global then local. From here, what you want to do is select your points and add your control points. So that'll load the control points into this control points panel and automatically detect which runs have been matched. You go through and you start picking your points just like you would in photogrammetry. There's a few options here. The targets and residuals will then load in this section here, and then you hit compute whenever you've picked all your targets, and you would apply that once you're happy with that registration. Often I would suggest do a global shift first, a global registration type. That'll give you a better indication of what your residuals are. So you'll see your residuals for X, Y, Z for each target, and then you can make an informed judgment whether you want to keep those residuals and keep the global shift, or move forward to a global then local registration type. Register a run is similar, but it's just being applied to an individual run. Same tool, same function, but it's just applied on a local level. Register run to run. This is where after you've adjusted one run, you might want to do a cloud to cloud registration type. So you could give it a name, pick the pair. So if I wanted to adjust run 1 to 2, 2 to 1, you add it here. You reference one, you add a second one, and so forth. So you kind of build up a list of how you want the cloud-to-cloud registration to work. This tool here is often paired with the register a run tool. So if you go down the register a mission avenue, you don't really need to use these 2 functions. Once you've registered your mission, you will probably have another SBET, another smooth best estimate trajectory underneath it. If you wanted to, and you're happy with your new registration, make sure you either update the scans to accord with your latest trajectory. So just reiterating that, once you re-register a trajectory, just ensure the point cloud you're viewing and you're looking at is on the most current trajectory. That can be something that catches people out. They've gone through this trajectory processing, they've registered the run, and they're like, oh, my point cloud still isn't right. Well, you just need to generate the point cloud on the new trajectory. You can either go through the generation process or the update scans. Either or works. From here, there's a few different viewing methods. So we've captured all this imagery as part of this runs. We want to use them. So if I wanted to select and view the panoramic image here, a lot of the options are actually available in the right click. So if you right click a particular run or mission, it'll give you all these options of tasks available. So I could select panoramic view here, or as mentioned, there's often multiple avenues to do that. So you can see up the top here, panoramic view. I could hit that, and that will open my 360 imagery. You can see here, this is my run 10. Now, this is often best used in conjunction with the 3D view. So what I can do is if I right click my pane tab up the top, I can actually force it to do a vertical tab group. And that means I'm looking at two different data sets at once. If I go back to my plan view here, it's hard to tell where this is. So it's kind of, you want these to be cohesively talking. And you might be interested in this poll. What you can do is if you hit this center plan view, it will automatically drag your view to the center of where you're viewing. If I zoom in somewhere over here, you can see as soon as I hit that, it comes to where my station view is, and you can see exactly where I'm looking. So I can quite quickly go and look at what pole I'm interested in, as well as zooming in. It kind of, the field of view matches what you're looking at. That's this little button here. If you're in a 3D view, you can do the same. So if I zoom out, you can do the same here, but it's a bit less intuitive. It doesn't have that field of view. What you can do is hit this 3D sync view here. Match my two views together. So you can see pretty quickly. It's a pretty powerful tool. In conjunction with that, you can take advantage of the classification. So in this data set, I have gone through a point cloud classification workflow. What I've done is selected the whole point cloud region, done a terrestrial classification type. Depending on your environment, you can select different types. This is the most successful for mobile mapping, and it's broken all my point cloud into all these regions. If I turn on my region colors, you can see that in practice. So this can be quite a good tool. As well as using my view filter manager, which if you don't have my view filter manager, if you don't have that toggled on down there, it is up the top here. I can go turn off particular data types. So I'm going to get rid of all this noise here. All that noise is gone. I've got a bit of a cleaner data set that I can go and do some measurements on if needed, or extraction workflows. We have a rear-facing camera. So what I can do is also open my backwards view. And you can see here, this is my rear imagery. Rear imagery, this is what it looks like. There's a few workflows under this analysis group here, where we can create an ortho image for the lane to create one cohesive image of the data, or we could do some pavement inspection workflows, which you can just follow this through. So select particular run. You do need to extract the lane lines before you run this, just so it knows what it's analyzing. And there's some analysis parameters that you can go through. From here, there are multiple different extraction types that you can utilize. Point feature extraction, where you can extract the trees. If you load a feature code library, you can map the attributes. So you go through, pick the trunk, etc. If you need more information on extraction types or lane extraction, line extraction, track geometry, stockpiles, advanced filtering, that's probably best in another video rather than talk for hours. From here, we might want to do some exporting to do, if you wanted to share this data into other platforms. There is in our home registry a publish to triceps, which is our Trimble reality capture platform service where you can load it up directly to a particular Connect project and share the data in a multi-pane viewer type. If you want more information on that, I've got another video on those. Standard exports for sending elsewhere. There's a mobile mapping group where you can do some intelligent exporting. This last split trajectory will split the trajectories at set distances. If you wanted some Topo exporters, Solve3D, TMX is our proprietary software where you can export all these individual point clouds, or if you wanted to, you can do a standard LAS export. You can export it at different formats as needed. That's a quick rundown of our mobile mapping processing workflow. There is heaps of different avenues to take. If you have any questions, please reach out to myself or anyone, and we'll be happy to spend a bit more time with you going through those workflows. Thank you.